to talk a little bit more about solving a particular type of differential equation called separable differential equations. And the best way to do this is going to be through examples. So let's start doing some examples. I have dy dx equal to cosine x. Well, we've talked about in the past how we want to integrate. And when we integrate, we need to integrate both sides with respect to the same variable. In this case, x. On the left, you can see I have a dx over dx, so that's just the integral of dy. The integral of dy is going to be y, and the integral of cosine is sine, plus c. We also have this initial condition that says this is equal to 2 whenever x is 0. We know that sine of 0 is 0, so c is 2. So I have my solution y equal to sine x plus 2. Let's look at one more of these and then we'll move on to something a little more complicated. I now have dy dx equal to 2x plus 3. When I integrate, integral of dy dx dx, and the integral of 2x plus 3 dx, the left becomes the integral of dy. And then when we integrate, the integral of dy is y, the integral of 2x is x squared, the integral of 3 is 3x, plus my constant of integration. I do have an initial condition here. So I know that when x is 1, y is 2. So now I have 2 is 4 plus c, so c has to be equal to negative 2. So my final answer, x squared plus 3x minus 2. So these have been fairly easy because all we had to do was integrate both sides. But now we're going to introduce an extra step into that. Before, whenever I did these, I didn't have any extra y's. The right-hand side was all x's, and this time I have a combination of x's and y's. And so the trick to this is essentially get your x's on one side and your y's on the other. I'm going to divide both sides by y. So now I have 1 over y dy dx equal to negative 2x. And now I can integrate both sides. On the left, the integral of 1 over y dy dx dx. On the right, the integral of negative 2x dx. Once again, my dx's cancel. I have 1 over y dy equal to the integral of negative 2x dx. The integral of 1 over y is ln of y. The integral of negative 2x is negative x squared plus c. And now we do have one extra step after this as well, which is to solve for y. So in this case, y is e to the negative x squared plus c. Let's look at this one. Once again, we still want our y's together, so I'm going to multiply both sides by y. When I integrate both sides, I'm going to go ahead and cancel the dx's on the left. The integral of y is going to be 1/2 y squared, and the integral of 1 is going to be x. And now we still have to solve for y. So I have y squared equal to 2x plus c. And then taking the square root, y is plus or minus the square root of 2x plus c. Let's do a couple more. Here, I have dy dx plus 2xy squared equal to 0. So the real trick here is to realize that whenever I have my y's on one side, I need to have a function of y times dy dx. So I'm going to need to either multiply or divide by something to actually make this work correctly. So I'm going to subtract the 2xy squared over and then divide by y squared, which I'm going to go ahead and write as y to the negative 2. Then when I integrate, the left becomes y to the negative 2 dy, the right negative 2x dx. We add 1 to the exponent and divide by that number. Same thing on the left, add 1 to the exponent and divide by that number. I can then multiply through by -1. I then have 1 over y equal to x squared minus c. I can take the reciprocal of both sides to get y equal to 1 over x squared minus c. And now I'm going to use my initial condition. Y is 2 whenever x is 0. So I have that c is minus 1/2. So y is 1 over x squared plus 1/2. For my final one, I'm going to look at dy dx equal to e to the xy. And the trick here is to realize, well, first off, if I play with properties of exponents, I get e to the x to the y power. Well, anytime we try to get rid of powers, we want to take the ln of both sides. And this is instantly going to cause a problem. Because of this, I don't know how to deal with ln of dy dx. And so this is actually not separable. So we would need more advanced methods to actually solve this differential equation. If you're interested, I highly suggest you take a differential equations course, but for the purpose of this class, we're going to just say that we can't do this.